Good morning, students. Here I am with the topic of machine design, that is stress strain diagram. Stress strain diagram for ductile material. Suppose what are the ductile materials? After application of tensile load, what happens? They are converted into wires, length increasing length, ductile materials. So my stick is ductile material and copper is also ductile material. So here I have drawn a stress strain diagram for ductile material. For example, it is a stress strain diagram for my steel. So different points are there. O, A is the proportionality limit. A is the proportionality limit. In this, what happens? Stress is proportional to strain. Then AB is the elastic limit. BC is the plastic deformation. And C is the upper yield point. And D is the lower yield point. And E is the neck formation. And F is the fracture of the material with formation cup and cone formation. Now, how to draw the stress strain diagram? On the x-axis, we plot the strain. We have already defined in the previous lecture what is strain, that is change in length upon original length. And on the y-axis, stress is plotted. That is, stress is defined as the load upon resisting area. So stress is plotted on the y-axis and strain is plotted on the x-axis. Now what happens? How it is plotted? How the stress strain diagram is plotted? Suppose this is a piece of mild steel and I applied the tensile load. What happens after application of tensile load? After application of tensile load, it increases, it goes under deformation. There is increase in length. Correct? So, suppose I apply a load of 10 kN. After application of 10 kN, there is increase in length. Say that increase in length is delta L1. Delta L1. Then delta L1 upon L will be the corresponding value of the strain, and load 10 kN upon resisting area will be the corresponding stress. I will plot that point. Suppose this is stress is plotted and here strain is plotted. This is the point. After removal of load, material regains its original length. Means material is elastic. Then after getting one point, how we get the second point? Suppose I increase the value of load, that is 20 kN. I apply a load of 20 kN. Then increasing length will be, delta L will be more. Suppose delta L, the value is delta L2. That will be more than delta L1. I will calculate the strain and corresponding stress. Then I will plot corresponding stress on x on y point and corresponding strain on x axis. In this way, I will plot, I will get the points and I will join. Up to the point A, what happens? Stress is proportional to strain. Hence, OA is known as proportionality limit. Means, according to Hooke's law, what happens? Stress is proportional to strain. So, within elastic limit, what happens? OA is the elastic limit. In this, stress is proportional to strain. Now, after getting point A, suppose I get a point at A point at 100 kN. I increase the value of load. Suppose 125 kN, I apply a load of 125 kN. Then what happens? There is increasing length and there is, suppose delta L is the value, corresponding strain will be there, corresponding stress will be there. What happens? But stress is not in this A to B. Stress is not proportional to strain. Though it is elastic limit, after removal of load, material gets its original length, but stress is not proportional to strain. A, B. So up to the point B, it is an elastic limit. Points A and B are very close to each other. So up to the point B, that is elastic limit. After B, what happens? After B point, what happens? If I increase the value of load, what happens? After removal of load, the length remains increased length. Means material do not get its original length. So that is the plastic deformation. That is the after point B. Suppose I apply a load of 155. After removal of load, the increased length remain there. So plastic deformation is there. So this happens up to the point C. So up to the point C, maximum yielding takes place. Yielding means plastic deformation. Up to the point C, maximum yielding takes place. Then what happens? After point C, without increasing load, there is deformation. So we will get point D, that is the lower yield point. This point D is known as lower yield point. So at point D, what happens? Due to strain hardening, material regains the strain. After getting the strain, what happens? More load is required for the deformation, and this happens up to the point E. At E point, neck formation is there, and here what happens? Still we increase the value of load, then the fracture will be there. At point F, there will be fracture with the cup and cone formation. So this is the sample of rod performed the tensile test on UTM. So here cup, this is the cup and this is the cone. So specimen breaks with cup and cone formation. So this is all about the stress strain diagram. So we will meet in the next session how to draw stress strain diagram for the brittle material. Thank you. Here we end the session. We will meet in next session. Thank you very much.